Okay, so then as promised, we'll start off this week by talking about more mixture problems. We just did a couple of examples last week. Remember, the key to mixture problems is we have some substance, some sort of, we're going to call it serum, is the generic term for a medication that we're going to use, that is dissolved into some sort of a solute. Sometimes the solute is called a diluent. Not a big deal to have all the terms down right now. But the amount of the serum in a solution, remember, is equal to the concentration, or the percent as a decimal, times the volume of the solution. So if we have 800 milliliters of a 17% solution, that means that the amount of serum in that solution, 17% is 0.17 as a rate, times 800 milliliters. Is 136 milliliters of that serum, of whatever that medication is. So and as we're looking at these mixture problems, what we have to remember is the total amount put in has to equal the total amount of serum that is in the result. So if we have 400 milliliters of 18% solution and 200 milliliters of 30% solution, to find what percent we're going to end up with, well, what's being put in? Well, we have 18% and 30%. And what is going to be coming out, or what's going to be in our result? Well, we don't know what percent that is quite yet. So for each of these, we're going to start out with the 400 milliliters of 18%. That'll be 0.18 times 400. Plus, we got the 30%, that's 0.30, or just 0.3 is the decimal for 30%, times 200 milliliters. Now, on the other side over here, it's the percent that we're looking for. So that rate, that decimal, is our variable. And how much of it is there going to be? Well, 400 milliliters plus 200 milliliters. The total of the two inputs here. Now we just have to work on solving the equation. So we have the 0.18 times 400 is going to be 72. 0.3 times 200 is going to be 60. Over here, x times 400 plus 200 is 600. And we can combine here. 72 and 60 make 132. That is 600x, and we're solving for x. 600 multiplies the x, so to get rid of it, we divide by 600. Which is going to give us 0.22 equals x. Changing that to a percent is 22%. Any questions? Now, of course, the problems we're looking at aren't set up quite that easily. We're not given the amount of both of the ingredients and asked to find what's the percent of the result. We're given the percentages of everything. We're given the amount of one of the ingredients and then how much result we want, and we need to figure out what the other ingredient is. For example, we might say that we have 42% and 52% solution on hand. We need 44% solution. How much of the 52% solution? do we need to mix with 240 milliliters of the 42% solution to get that desired 44%. So the ingredients here that we are mixing together, we have the 42%, so the 42%, the 52%, and we are getting a 44% result. 42% is going to be 0.42 as a decimal. Do we know how much of that we are using? 240 milliliters, yes. 240 milliliters of the 42%. And I'm going to leave the milliliters off just to make it easier to write my equation here. To that, we're going to get the 52%, which is 0.52. We don't know how much of that. That's what we're asking, is how much of that 52%. So X is going to be the amount of the 52%. And we want to have 44%. That'll be 0.44. Do we know its amount? Well, there we go. Yeah, just like in the equation up here, we had to do 400 plus 200 to get that amount. Same thing here. 240 plus X, or X plus 240, however you want to write it. So now it's a matter of simplifying the equation. We have 0.42 times 240 gives us 100.8 milliliters in that one. 0.52 times X is just 0.52X. Over here, we're going to have to distribute. 0.44 times X is 0.44X. 0.44 times 240 will give us 105.6. So now we're solving the equation. We see that there is an X on each side of the equal sign. So we have to get rid of one of them. 0.44X is the smaller one, so that's the one we're going to get rid of. So we're going to subtract. We're going to take away 0.44X. It's now gone over there. All that's left is the 105.6. But remember, if we remove something from one side, we have to remove the same thing from the other. So we have to take 0.44X from the other side of the equation as well. We can only take that away from other x's. So 0.52X minus 0.44X is 0.08X. So 108, or 100.8 plus 0.8X, or 0.08X equals 105.6. Now we have this in an equation that we can start to solve for X. First thing we're going to do is, perfect, subtract the 100.8. I have to do the same to the other side, which will give us 4.8. So 0.08X equals 4.8. And now it's just a matter of dividing by 0.08, giving us that X equals 60. So if we go back up to the top, make sure we know what X stands for. X stands for the amount of the 52% solution. That's going to be 60 milliliters. Now you have to ask yourself, does this make sense? The best way to answer that question is to look at what you're starting with. We're starting with 42% and 52%. And then what you're ending up with, 44%. If this resultant number is pretty close to being right in between the two of the ingredients, like in this case 47% would be exactly in between. So if that were 47%, you would expect these two amounts to be pretty close to equal. In this case, however, 44% is much closer to the 42%. Since it's closer to the 42%, you would expect there to be more of the 42% in the mix. And in this case, there is. There's 240 milliliters of the 42%, only 60 milliliters of the 52%. So it makes sense. That doesn't guarantee us our answer is right, but it definitely catches us if we've switched two things around somewhere and did it backwards.
I have a question.
Yeah.
When I went through the problems, number 11, what do you do when it says it contains no?
Okay, very good. I'll grab the book here. What page is that?
Page 54.
54, number 11. Let's take a peek at that one. So number 11 on page 54. How many liters of 12% sodium chloride solution should be mixed with 1 liter of solution that contains no sodium chloride? So in other words, 1 liter of what we call a neutral solution. Its percent is 0% for its concentration. It looks confusing, but it's going to go into the formula exactly the same way. We want, in this case, we want a result that is 4% NaCl. So 4% sodium chloride. So our ingredients here, 12% and 0% are going to try to give us 4%. Now again, before we even start, the 4% is closer to the 0, so we're expecting to use more of the 0%, more of the neutral solution here. We have 1 liter of that neutral solution. We're looking for how much of the 12% solution, so that'll be 0.12 times x plus. This is where it gets a little tricky because this is going to actually disappear on us. 0.00 is the 0% times 1, which of course is going to be 0. Yeah. That's okay. So then over here we're going to have the 4%, 0.04. It's going to be x plus 1 is the amount. So now 0.12x is just 0.12x. This is 0, so we don't need to worry about it. Equals 0.04 times x is 0.04x. 0.04 times 1 is 0.04. And now we have an x on each side. Again, here's our equal sign. There's an x on each side, so we need to get rid of 1. The smaller one's 0.04, so that's the one we're going to get rid of. So subtract 0.04x to make that go away. Leaves us with just the 0.04 over here. Subtracting 0.04x here gives us 0.08x. And now to get x by itself, it's multiplied by 0.08, so we're going to divide by 0.08. Gives us that x equals 0.5. This was 1 liter, so that 0.5 is also a liter. So 0.5 liters, half a liter of the 12%. Does that make more sense? Yeah. Well, that is kind of tricky. We haven't done any examples like that yet. And it could be the same way if you're mixing like a salt solution. How much pure salt you add, well, then that would be 100% that you would use for that. Any other questions?
So it'd just be 1 then if we use 100%.
Yeah. Yep. Any others off the homework that you want me to go over? Okay, well, we'll leave that. We'll let you guys work on those more, and we can go over more of those next week if we need to. Not all of the equations we work with are quite as simple as the ones we have here. There are more complex ones. And we can start dealing with fractions in our equations, running into ones like this. This is probably one of the simpler ones we can look at. This equation here can be interpreted in 2 different ways. You could interpret it as x has been divided by 7. So to solve it, we're going to multiply by 7. So x equals 56. And that's actually probably the simplest way to interpret this equation. But there's another way it could have been interpreted. X over 7 can actually be thought of as 1/7 x. Now in this case, this is a little more complex to think of it this way, so we'd probably go with what we did over here. But anyway, in this, if we think of it as 1/7 x, then to solve it, we have to divide by 1/7. Well, 8 divided by 1/7 is the same as 8 times 7, so we're still going to get x equals 56. Because we better get the same result for x either way. The reason I show you this method here is because we will run into equations where we have to think of it in that way. For example, you might have x over 9 plus x over 4 equals 39. Looking at this one, it would be a real bear to solve. We look at it, x is divided by 9, but x is also divided by 4. So it's really kind of tough to deal with in our traditional way. But if we look at this as being 1/9 x plus 1/4 x equals 39, well, then we can work with this just like we have many of our other equations. With the fractions in it, it looks more difficult, but it really isn't. This is going to be very similar to having 2x plus 7x equals 27. What would we do in an equation like this one here? Yeah, we would combine like terms. 2x and 7x make 9x. Then we'd go from there. Over here, we're going to do the exact same thing, only it's not nice little whole numbers like 2 and 7 anymore. It's 1/9 x and 1/4 x. Either way, we're still just going to add 1/9 and 1/4, and that's going to be the coefficient on x. It's just a little trickier to add 1/9 and 1/4. We need a common denominator, which will be 36. 9 times 4 makes 36, so 1 times 4 is 4. 4 times 9 makes 36, so 1 times 9 is 9. 4 plus 9 makes 1336. So what that means is this is 1336x. When we add 1/9 x and 1/4 x, we get 1336x. How would we solve that? Divide by 1336. That's no big deal, right? So we get x over here. 39 divided by 1336 is a little bit of a chore. 39 over 1 divided by 1336. We're going to make that 39 over 1 doesn't change. But instead of divided by 1336, it's going to be times 36 over 13. We can do some cross canceling here. The 13 and 39 are both divisible by 13. That'll give me 1 and 3. 3 times 36 is 108. 1 times 1 is 1. So x equals 108. We can run into fractions in our equations in other ways. Like this. Now again, some people look at this and they freeze up. This equation here is no different than having 5x plus 2 equals 32. On this equation, where would we start? We would subtract the 2, right? So same thing over here, we're going to subtract the 5/6. So that's gone over here, leaving us with just the 2/3 x. Over here, 1 and 1/4 minus 5/6, we need a common denominator, which will be 12. 4 times 3 makes 12, so 1 times 3 is 3. 6 times 2 is 12, so 5 times 2 is 10. Now we're subtracting here, so we're going to have to borrow from the 1. This will be 0. That one whole number there contains 12 pieces because we have a denominator of 12. So 3 plus 12 is 15 twelfths now. We just changed the 1 and 3 twelfths into an improper fraction, so it's 15 twelfths. And now we're subtracting. 15 twelfths minus 10 twelfths is 5 twelfths. So our 2/3 x equals 5 twelfths. Again, this is nothing more than just how we solved our other equations. It just takes a little longer and it looks a little more complex because there's fractions involved. Now that we have that, what's our last step? Divide by 2/3. Good, make the 2/3 go away. Over here, dividing by 2/3 is going to be a little trickier. So 5 twelfths divided by 2/3. You're tempted to cross cancel there, but we can't yet because it is still division. We're going to change this to times 3 over 2. Now we can still cross cancel. 12 and 3 you can divide by 3 to give me 1 and 4. 5 times 1 is 5. 4 times 2 is 8. X equals 5/8. Not so bad? Well, let's keep going with it. Let's try this one. You guys tell me what to do. Add 3 and 1/4. Perfect. That'll be gone. 1 and 1/3 x equals. Now, those of you that have a fraction calculator, all of you guys figured out how to use the fraction function in the calculator? Is there anybody that hasn't? You got a little key. Looks like this. It's the ABC key that allows you to enter fractions. It works wonders. If you have any questions on how to use it, let me know on break and I'll go over it with you. So anyway, we need a common denominator, which is going to be 8. So this is going to stay 2 and 5/8. This is going to become 3 and 2/8. 4 times 2 makes 8, so 1 times 2 is 2. We add those together. 5 and 2 make 7/8. 2 and 3 is 5. We have 5 and 7/8. So now we need to solve for x. To do that, we're going to divide by 1 and 1/3. So here we have just x. 5 and 7/8 divided by 1 and 1/3. We need to change those into improper fractions. 5 times 8 is 40, plus 7 is 47/8. 1 times 3 is 3, plus 1 is 4/3. Again, we can't cross cancel yet because it's still division. 47/8 won't change. Instead of divided by 4/3, it's going to be times 3/4. And now, unfortunately, nothing can cross cancel. 47 times 3 is 141. 8 times 4 is 32. Changing that back into a mixed number. 141 divided by 32. You get 4 here. 8, 12, 13 left over, so that's 4 and 13, 30 seconds. How's it going? The fractions are still a little scary, but it's not so bad, right? Our fractions can come in a little bit different way. You might have something like this. Now remember what this symbol means. It does mean divide, but it's called a fraction bar. And recall what it means. It means it's an enclosing symbol from our order of operations. It means you're going to do everything on top first, and then everything on bottom. In this case, there's nothing to do on bottom. And then you're going to divide. So what that's telling us is when this equation was built, the last thing that was done was dividing everything by 2. So as we start to take this equation apart, the very first thing we have to do is get rid of that 2 by multiplying by 2. So that'll be gone, and it leaves us with 3x minus 13 over here. It just takes off that dividing by 2. Well, on the other side, we have to multiply by 2 as well. 4 times 2 is 8. Next, we're going to add 13. 3x equals 21. And divide by 3. So x equals 6. Any questions? Okay, continuing with our fun with fractions. Tell me what to do with this one. Multiply by 2/3. Very good. That makes that go away. Leaves us with 3/4 x minus 1/2 over here times 2/3 over here. Well, again, 1 and 1/2 is going to be 3/2 times 2/3. Well, that's just going to be 6/6 or 1. We have 1 here. Now what? Careful. Add the 1/2. There we go. So 3/4 x. What's 1 plus 1/2? Just 1 and 1/2. Very good. And then divide by 3/4. So 1 and 1/2 divided by 3/4. 1 and 1/2 becomes 3/2 times 4/3. 3's cross cancel to give you 1 and 1. 2 and 4 cross cancel to give you 1 and 2. That is 2/1 or just 2. X equals 2. One more similar to that, and then we'll move on to something else. Looking at this one, we see the parentheses. And it's really tempting to start there. In fact, we do have to kind of check something there before we go on. In the parentheses, is there anything that needs to be done? Yeah, there's nothing to be done in the parentheses, but we can do something to the parentheses, which is to distribute. So we can distribute by the 5. 5 times x is 5x, and then 5 times a -8 is -40. Now that divided by 3 is still underneath it, and it still equals 10. Now what do we need to do? Times 3, good. So 5x minus 40 equals 30, and then add 40. 5x equals 70, and finally divide by 5. X equals 40. Better than a sharp stick in the eye? Okay. Good. Sometimes we'll run into an equations that don't have numbers in them. You know, we've solved an equation like this. Where we simply subtracted the 7, get 3x equals 15. And then we divided by 3. X equals 5. What if it looked like this, however? Of course, when it's set up like this, you have to specify which one of those letters or variables you're solving for. So we're gonna specify that we're solving for x. The steps to solve this are exactly the same. It just looks a little different because the letters and variables don't combine quite as easily as the numbers do. But just like our first step over here was to subtract the 7, over here our first step is going to be to subtract the b. So all that's left over here is the ax because we took away the b. What is c minus b? C minus b. There's no way to combine them. And then we have to divide by a. So the a is gone. We're left with just x. Well, c minus b divided by a is just c minus b over a. So, I mean, it's a little different, but it's not too horrible. This might come into play with some of our like power formulas and stuff like that. If we have something like this and we're asked to solve that for I. is a little different than anything we've done, but it's can reason through it the same way. To get I by itself, we're going to have to divide by the R. P divided by R is just P over R. Now, we haven't run into anything like this yet where it's something squared. What's the opposite of squared? Square root. Very good. And we have to take the square root of the whole side of the equation. So over here it is the square root of P over R is inside that square root. Over here the square root and the squared cancel out. We just have I. So that is the solution. I is equal to the square root of P divided by R. We start talking about conversions here next week. One conversion we'll do is temperature conversions. Medical field is going to degrees Celsius from degrees Fahrenheit. So if we have something that's in degrees Fahrenheit and we need to know what it is in degrees Celsius, we have this formula here. But what if we need to go the other direction? If we know the temperature in Celsius, then we have to convert back to Fahrenheit. Well, we could always put in the number here for Celsius and then solve the equation. But if we're going to do that with a lot of different temperatures and we have to do it over and over again, it would be nice to rearrange this equation so it wasn't so much work every time to solve it. So we could solve this for F. Now normally we would take and we would multiply, we would distribute this 5/9 through here. Rather than doing that, I'm going to do it a little bit differently, and I'm going to just divide by the 5/9 on both sides to get rid of it. It avoids me having some really ugly fractions in my problem. So if I divide by 5/9, this goes away because this whole side of the equation is multiplied by 5/9 right now, so I can divide by it and make it go away. So C divided by 5/9 is the same as C times 9/5, which is just 9/5 C. And that's going to equal the F minus 32. I was able to drop the parentheses from around it because there's nothing else over on that side of the equation anymore. So there's no need for the parentheses. And now to solve that, all I have to do is add 32. Well, 9/5 C plus 32 is just 9/5 C plus 32. So now if I have the temperature in degrees Celsius and I want to get to Fahrenheit, I just plug in the number and I do the order of operations in the formula. So let's do some examples of that. If I actually have a temperature, let's say I have, let's start out with human body temperature of 98.6 degrees Fahrenheit. If I want to convert that into degrees Celsius, I have to use that first formula I had. So the Celsius is equal to 5/9 times F minus 32. Where does 98.6 go? That goes in there for F. That is the temperature in degrees Fahrenheit. So C equals 5/9. 98.6 goes in for F. What's the first thing I have to do now to reduce this? There you go. There's all numbers here, so I can actually do what's in the parentheses now. 98.6 minus 32 is 66.6. Now then to find C, I'm going to multiply by the 5/9. 5/9 times 66.6 is 37. Any questions? Okay. What if I wanted to go the other way? What if you're listening to the news? Maybe you're in a foreign country or somewhere where they're going to give the weather in Celsius, and you're told it's going to be -2 degrees Celsius. Now, to us, -2 degrees is a pretty cold day, but if that's Celsius and not Fahrenheit, is that really cold? Where a Fahrenheit temperature is going to be 9/5 times Celsius plus 32. We just came up with that formula. Where'd it go? Up here. So let's put in the -2. So 9/5 times -2 is a negative, make that -2 over 1. That's a -18 over 5. Or -18 over 5 can be thought of as a -3.6. -3.6 plus 32 is 28.4 degrees Fahrenheit, which is chilly but not a terrible day. In the medical field, there are formulas like this outside of temperature that we use. For example, if we want to convert pounds into kilograms, or the other way around. A person's weight in pounds is equal to 2.2 times their weight in kilograms. So if a patient is listed as 45 kilograms, get their weight in pounds, I'll just 2.2 times 45, which is 99 pounds. Or a little bit more complex equation. Body mass index. Your body mass index is equal to your weight divided by your height squared times 703. Now your weight is going to be given in pounds. Your height is going to be given in inches. So if you have someone who has a weight of 180 pounds, a height of 71 inches, that's 5'11". Let's find their body mass index. So 180 goes in for W, 71 goes in for H, that's going to be 71 squared, and 703. Now the first thing I would do if I was doing this by hand, here we have to do, there's nothing to do on top, that's just 180. But on bottom we do have the 71 squared, which is the 5,041. Then we have to divide. 180 divided by 5,041. Gives 0.03, and then times the 703. 25.1. It's a BMI of 25.1. Now, our calculators are capable of doing this all in one step. If I were actually calculating this, I would do it that way. I would just do 180 divided by 71, use the x squared key to square it, and then times 703. And I still get the same result. Any questions? A little early for our break, but let's go ahead and do it anyway. Let's come back about 9:20. Let's go 9:25.